welcome to this video. In this section, we are going to focus on how to control the GPIO peripherals on various boards using Zephyr. So I'm still going to use the playground project or application that I created in the last video, and this is what we are going to use for all the peripherals that we want to control. Like I said, if you are in the applications management view of Zephyr Workbench, what you see is different from when you actually go to the Explorer and then you look at your code. So let me minimize everything except the playground here. You go to SRC and then you open main. In here, you can see that I have cleared everything, and my target board here is the STM32F4. I want us to use the GPIO, like you already know, to be able to control some pins, turning them on and off and slipping in between. So I'm going to show you the user manual for my board, because this is the document that tells us which pin on which GPIO controller a particular LED on the board is connected to. So you can just Google STM32F407VG user manual, and these documents are usually the shortest ones that you can find. So there's the user manual, there's the data sheet, there is the reference manual. What you want to read in order to know what pin is connected to what component on the board is usually the user manual. So I'm going to go through the table of contents, and let's find out about the LEDs. So I'm looking for LEDs, which is here on page 21. And here you can see that there is LED 1. It says is the default status red, blah, blah, blah. I want one of the user LED. So a user LED is basically an LED that you can write code to control. The ones that are not user LEDs means they are used by the board for specific purposes, right? So let's just choose, let's say the blue LED, right? So it's called user LED 6. And here it tells you that it is connected to IOPD15. So this information is very important. PD, it means it is on port D. So the GPIO controller here is the GPIO D. And the very pin to which this LED is connected is number 15. Now, Zephyr has many ways of achieving the same thing, especially when it comes to GPIO, and I'm going to show you at least 3 ways of doing that. The first approach I'm going to show you, we are going to assume that a device tree definition for the GPIOs have been created. And even though I have these files already opened, maybe let me close them, then I can show you how to access them on your own, right? So if I come to where my SDK is, I go to my workspace. I'm targeting STM32 here. I think depths. I go to Zephyr and I go to boards. These are where the device tree source for the various supported boards are defined. I am using an ST micro controller. So I go to the ST folder and I look specifically for STM32F4 discovery. So this one here. Once I get in here, I can see the device tree source here, but it's just 4 kilobytes. It tells me it doesn't have a lot of content in there, no problem. But at least I can look at this and then I see that green LED 4 is connected to GPIO D pin 12, right? Red LED 5 is connected to GPIO D pin 14. And if you go up, you can see that this also includes the STM32407XG file. So it means, like I explained in the previous video, is a hierarchical structure. And so some of the DTS or device tree source is on the board level and others are on the SOC level. And because every board has a system on chip, it makes sense to include the device tree source for the sock and then add only the few things that are needed for the board. And this is what is going on here. But at least since this is a reference, I know that somewhere there is a node called GPIOD and I am able to access that in code. So let's see how to do that. Let me maximize this. The first thing is to include the needed headers, right? So I'm going to include Zephyr, and then the first one is kernel.h. This is the kernel, like the core of Zephyr. So things like sleep, print, and all those things, they sit in this header file. And then now we have to get the GPIO driver itself. So include, and then we do Zephyr /drivers /GPIOD. All right, cool. And then let's define our main. So our main takes no argument, and then this is it, right? So far so good. If I come to Zephyr Workbench, we should be able to build this project without any challenges. Okay, that's fine. So now the next thing we want to do is let's define our target pin. We could see from here that let's say pin 15 is going to give us the blue LED, right? So I will come here and then I do define LED pin, and that is 15. Okay, so this is just how we are going to target that particular pin. Now pay very close attention to the code I'm going to write on line 7. It is a similar thing you are going to use regardless of which peripheral you are going to access in Zephyr, right? So you say const struct, and then so the data type or the struct type here is called a device, and you need a pointer to it. So I'm going to call this let's say GPIO dev. It's any name that you choose, right? And then I'm also going to declare an integer called return. This we are going to use many times because many of the functions in Zephyr returns an integer to indicate whether they were successful or not. Usually if a call to a function isn't successful, you get a number less than 0. If it is, then you get a number 1 or greater than 0, right? So usually you see this construct a lot in Zephyr code bases. Okay, now how do we actually get access to the GPIO controller that we want to use? Again, there is a macro available in Zephyr. So we now come here, and then this is where we are actually assigning a device driver, the particular device driver, to our GPIO dev. And you'd say dt get. All right, so this device dt get is going to use the device tree definition, which you can see in the file that I opened here, because this is for the board that we are using. So just make sure you look for the right device tree source for the right board, right? And then you have to tell it the name of the node which has been defined for the GPIO controller that you want. We want GPIO D, and how do I know? Because it says PD, so port D. Port D is the GPIO controller D, and then 15 is pin 15, right? So I say, give me a device driver, and then I'm going to look it up with DT node name. Remember, node label. I mentioned this when I was introducing Devicetree. So here, GPIOD. So you can see that this GPIOD is neither in single quote or double quote, right? This is where the magic of the Zephyr build system comes in. So remember I said the device tree source actually gets compiled into a .h file that is included in your project. So the definition of this will come in when the build process or the toolchain is building the source code. This is why it's neither in quote, double quote, nor single quote, but it is still addressable, right? So now that we have this device dt get, we can actually, I mean, not like it's needed, but we can just compile and see. But I can see I have spelled the label here wrongly. So if I save this, let's just build this and see if everything's okay. Yeah, so everything is okay. And now the next thing we want to do is you want to check if the device is ready. It is quite a common convention in Zephyr, right? So the device DT gets, let me spend time here. The device DT get, it says gets a device reference from a Devicetree node identifier. So for every peripheral, you are going to use this device struct. And behind the scenes, Zephyr knows how to use function pointers and whatever construct is available in C to give you that concrete implementation that will help you to work with that particular peripheral. Whether it's UART, I squared C, SPI, what have you, this is the approach that you are going to use. So once you have it using the device tree, like the device DT get, what you have to do is to check whether it's ready or not, right? So I would say if it is not ready, so you say device is ready. So we are checking if it is not ready. So I'm checking if my GPIO device is not ready. If it's not ready, then I'm going to return some negative number to show that it didn't work as expected, right? And then now that if everything is ready, if the device GPIO controller is ready, then I can say return is equal to GPIO pin configure. Yes, this one. So over here, you need to tell it the device. So GPIO device, all right, and then the particular pin. So here we say LED pin. And then what is the flag, or what is the state you want the pin to be in? What kind of GPIO do you want? You know, GPIOs can be configured for input, output, or alternative function mode, right? So over here I say GPIO output. You can actually leave it here, but there are different flags also. So GPIO output just set it as an output, but it doesn't set it in a particular state, like whether it's on or off. But then there's GPIO active, GPIO high. All of these are going to set it as output and also leave it in a particular state. So for example, if I say output is going to be on the moment it's set it, or high the moment it's set it. Now I need to check if the return is less than 0, then it means it couldn't successfully um, configure that pin as an output or in the mode that I wanted. So then I'm going to return whatever negative value it also returned to indicate that there was an error. Now we have finished everything about configuration, so we come into our infinite loop, and what we do here is we set the pin high, we wait, and then we set it low also. So I say GPIO pin set, and then here again you have to tell it the device. So you always need a controller, so GPIO dev, and then I'm going to call it the LED pin, and then I want to set it high. There are constants high and then low for this, but you can also use 1 and 0. And then we say KM sleep. So this is how you tell the kernel to sleep for a number of milliseconds. So I'm going to sleep for 1 second, and then I'm just going to copy this and paste. So I'm going to set it off, and then I'm going to wait for 1 second. Here I build again, build successful, and then I'm going to flash the firmware onto the board. Flashing is done, so I'm going to switch to a place where you can see me hold the board in my hands. So you can see our target was the blue board, and indeed here it is flashing. Why not just change the LED and then blink another one? Let's do that. So let's go back to the user manual, and then let's choose another LED. So this one is a red LED, right? User LED 5. It is connected to PD, so the same port, so we can reuse the controller that we have, and then just change the LED pin, which is pin 14. So I come in here and then I just change 15 to 14. This is the good side of using constant and macro definitions for things that are repeated in your code. So I build this once again. I flash this. Code has been flashed, and I'm going to switch to a place where you can see me. And then here you can see that the color of the LED has changed from blue to orange. All right. So this simple code right here is one of the ways by which you can access GPIO controllers, given that you have defined them in your device source tree, which is almost always the case because whatever board or system on chip you choose already has a device source as part of the toolchain. So thank you very much for watching this. In the next video, I'm going to show you another strategy that you can use to control GPIO devices. See you.